Hey all, welcome to homeschool. Hope everybody are doing good and welcome back to class 11 physics. We started with the chapter motion in a plane. As a part of this chapter, we started with vectors. Vectors is one such mathematical tool which is very important, and we use this extensively to understand certain concepts of physics, right? So as a part of our study about vectors, we have completed addition of vectors in a detailed way. That is in my previous video. I discussed about triangle law of addition, parallelogram law of addition, and polygon law of addition. Not only that, we have completed some basic things, the types of vectors, right? And coming to today's video, I am going to discuss about subtraction of vectors, multiplication of vectors by a suitable number, and later the most important, resolution of vector, right? Okay. And in my previous video, we have also discussed about how to find magnitude of resultant vector and direction of resultant vectors in terms of theta. I mean, the analytical method we have studied. So coming to the first topic of today's class, that is subtraction of vectors. So how do we subtract vectors? To add vectors, we can use any three methods that we studied under graphical method, or we can use analytical method also. Fine. And coming to subtraction of vectors, suppose A and B are two vectors. So we have two vectors, A vector and B vectors. Okay. So we normally define A vector minus B vector as sum of A vector and minus B vector. Okay, see here, if you want to subtract B from A, if you want to subtract, B vector from A, just take negative of B, okay, inverse of B vector. Okay, inverse of B vector means minus. Okay, just the vector in opposite direction. Okay, observe this. This is your vector A and this is your vector B. Right. See, if I have to do A minus B, what I need to do, inverse of B vector is what? Negative of B vector. That means B vector was in this direction. Now I will take B vector as this direction. So this becomes minus B vector. Right? Now you concentrate. So this is your A vector. So I took negative of B vector. Okay, how do I get negative of B vector? Just changing the direction. B vector was initially like this. Okay, I changed its direction. Now it became minus B vector. Okay, so you just have to add A vector and minus B vector. That's what becomes the subtraction of vectors, isn't it? Say, how do you add A vector and minus B vector? See, draw a parallelogram law of addition you can do, isn't it? So just I'm making a parallelogram and I'm drawing a diagonal out of it, right? So this is your resultant vector. So your resultant vector is equal to A vector plus of minus B vector. Okay, let me write it here properly. Resultant vector is equal to A vector plus of minus B vector, right? So ultimately it becomes A vector minus B vector, right? So that is how we can do subtraction of a vector, right? So when you have to subtract a vector, so it's very easy. Just take one of the vector in opposite direction. It becomes a negative vector, and that's how you can subtract B vector from A vector. That means A minus B vector. Okay, so now let's understand this with one particular problem, like how we can add a vector and how do we subtract a vector. See this question, two vectors of equal magnitude 5 units have an angle 60 degree between them. Find magnitude of sum of the vectors, difference of vectors. Very simple question. Two vectors of equal magnitude. So this is a vector A and this is a vector B, right? And they said the angle between these two vectors is 60 degrees, right? So that means your theta is 60 degrees. Fine. So you need to find sum of the vectors and difference of vectors. Magnitude of sum of the vectors and difference of vectors. So here, if you make a parallelogram, just draw a diagonal. So this is your resultant vector, which is equal to A vector plus B vector, right? So if you can find the magnitude of resultant vector, you will get answer for the first question, right? So how do you find magnitude of resultant vector? So R is equal to under root A square plus B square plus 2AB cos theta, isn't it? So this formula we have studied in our previous video. We have derived the formula and we have seen questions and applications of this formula also, right? So here resultant vector, our resultant vector is nothing but, magnitude of A plus B, right? Magnitude of A vector and B vector. Fine. So how do you find? Say magnitude of A is given. Magnitude of A, or I can just write it as A is given 5 units. Magnitude of B is given. I can represent magnitude like this, or just B I can write, which is equal to 5. So A is 5, so 5 square, right? And again B is also 5, 5 square plus 2 into 5 into 5, right, into cos theta. So theta is the angle between two vectors. They said the angle between two vectors is 60 degree. So cos 60 degree, right? So this is how you will calculate magnitude of, sum of the vectors. So sum of the vectors magnitude, this is how you can find with this particular formula. Okay. And now, okay, so this calculation is up to you, right? You can calculate. And coming to difference of vectors. So to find the magnitude of difference of vector, what do you mean by magnitude of difference of vector? A vector minus B vector you have to find. Okay. So what do you mean by A vector minus B vector? It is nothing but A vector plus of minus B vector. So this will be the difference of magnitude, of vectors, right? So magnitude of difference of vectors is this one. Okay. So now just construct here how we can find. See, how do I draw a figure here? So this is your A vector. This is your A vector, isn't it? And B vector was this. Now minus B, how do I do? I'll just extend, right? It was like this previously. Now I'll do something like this. So this is our minus B vector, right? And now rest of the thing is same. Make a parallelogram. And this is your resultant vector. What is this resultant vector? Resultant vector is equal to A vector plus of minus B vector, isn't it? Fine. Okay. And now you observe what is the angle between A vector and minus B vector. Okay, so this is A vector, B vector. This angle was 60, right? And the total angle was 180, right? So this angle was 60 here, the angle between A vector and B vector. Now I want the angle between A vector and minus B vector. That means this angle I want. So the total angle was 180. So you have to do 180 minus 60, that is 120 degrees. So your theta is equal to 120 degree, isn't it? So now the same formula you can use, right? So what is the magnitude of A vector plus of minus B vector? It is nothing but magnitude of resultant vector, or just R I can write, is equal to same formula here a square plus of minus b square, right, plus 2 into a into minus b into cos theta, right? So what is theta here? A is 5, B is also 5. Okay, so this is 5 units. A is 5, 5 square plus 5 square, okay, plus 2 into 5 into minus 5 into cos theta. Theta is 120 degree, right? So this is how you can find the magnitude of difference of vectors. Difference of vectors in the sense a vector plus of minus b vector. Minus b vector, how do you draw? Just it is the b vector itself, but in a opposite direction becomes minus b vector, right? So this is one simple problem on subtraction of vector. So now we will go for multiplication of vector by a suitable number. Look here guys. Say whenever you have a vector A, so A vector is a vector, and you know lambda is a real number, and when you multiply A vector with lambda, what happens is direction will not change. Okay, magnitude of A vector changes by a factor lambda. Okay, what I am writing is no change in direction. There is no change in direction. Okay, but magnitude of A vector changes by a factor of lambda. Okay, so one example I'll tell you. See here, you have A vector, and here I am multiplying this A vector with a real number. Let that real number, lambda is some real number, so let lambda be 2. Okay, so then what do I get? I get my new vector, that is B vector is equal to A vector into 2. Okay, so what happens here is B vector is equal to 2 into just magnitude of A vector will change. Okay, so A vector's magnitude is increased by 2 times. What is the meaning of this? A vector's magnitude is increased by 2 times. That's it. Okay, so there will not be a change in a direction, just you will find a change in a magnitude. Say A vector, I am multiplying with a real number 2. Then my new vector, that is B vector, is equal to A vector. It is A vector only, just multiplied by 2 in the sense what? Magnitude of A vector is increasing by 2 times. Okay, so that is the meaning that you have to understand. Right? Okay. So now if lambda is negative, here it was positive, right? If lambda is negative, that means let me consider lambda is equal to minus 2. Okay, so then my B vector is equal to minus 2 into magnitude of A vector. Right, so that means it actually becomes B vector is equal to minus 2A vector it becomes. So what happens here? Direction of A vector is getting changed. So when you multiply with a negative number, you know, direction of the vector gets changed. It becomes opposite. Directions are opposite. Okay, but here magnitude is to the same extent, isn't it? So magnitude, when you multiply with positive number or a negative number, magnitude wise it remains same, and you know, just the direction is different, right? So this is what you have to understand with multiplication of vector by a real number. Nothing much. Okay, so any vector when you multiply with a real number, you know, real number, what happens if the real number is positive? just magnitude gets changed. Say if the real number is 2, magnitude of A vector is increased by 2 times. But if the real number is a negative number, what happened? Magnitude is increased by 2 times. Magnitude of A vector is increased by 2 times. But along with that, direction of vector also will get changed. Right? So this is the conclusion of multiplication of vector by a real number. So now we will go for very, very important topic, resolution of vectors. See, here you need to understand proper meaning of resolution of vectors. Resolution means splitting of vector into its components. So what do you mean by splitting of vector into its component? See, let me take, this is a vector in x-axis. Okay, let me call it as AX vector. Instead of writing it as AX and arrow mark on this, I can also write this AS vector in the form of unit vectors, right? Say we have studied unit vectors in my first video. Try to understand, if any vector is in x-axis, then it is represented as, I cap. And if a vector is in y direction, then it is represented as j cap. If it is in z direction, then the unit vector is k cap, isn't it? Say for example, I have a vector moving in x direction, right? Let that vector be A. Okay, usually how do we represent a vector? A, on that an arrow mark. Okay, so instead of that, we can also write this A vector as, something like this, A vector dot I cap. It means that there is a A vector moving in x direction. So unit vector represents only the direction. So the moment I write I cap with any vector, it means that that particular vector is moving in x direction. Okay, say here I'll write B vector dot j cap. What do you mean by this? This particular B vector is moving in y direction. Okay, so that is the reason behind writing I cap and j cap. Okay, so this is a way of representing vector in terms of unit vector. Instead of just writing as A vector, okay, I can also represent in this way. I can include I cap along with A vector. It tells you that this A vector is moving in x direction. Okay, so this is a way of representing vectors in terms of unit vectors. Okay, so like that, say this is x direction, so AX is a vector, okay, moving in x direction, so AX dot I cap. See guys, understand, if I would have written just AX, it is not called as a vector. It is actually magnitude of this vector. Okay, but the moment along with AX, I have written I cap, in the sense this is a vector. Okay, so just instead of writing like this, AX arrow mark, now it's a vector, right? Instead of writing this arrow mark above, I can also write this AS vector something like this, I cap. Okay, so hope you understood the reason behind writing in this way, right? But if I had only AX, it is not called as a vector, it is just a magnitude. Okay, so AX dot I cap is a vector that is moving in x direction, okay, in x coordinate. Fine. And now this is our AY vector. Okay, if I would have written just AY, it is not a vector, it is like magnitude of this arrow, okay, whereas AY j vector, when I have written, then it becomes a vector. Okay, AY is a vector that is moving in y direction. That is what the meaning behind writing this format. Okay, fine. And now if I have to add both the vectors, on adding, I get a resultant vector, right? So this is our resultant vector, right? A parallelogram addition. So let the resultant vector be A vector. Okay, so A vector is a resultant vector. And let this angle with respect to AX vector, okay, angle between resultant and AX vector, that is the vector in X direction, let it be alpha. Okay, let it be alpha. And now actually we have A vector, right? So this A vector I will split into two components. I will split into two components. Okay, so I can split into X component and I can also split into Y component, right? So usually, how do we write? A vector is equal to, what do we write? Ax dot I vector plus ay dot j vector. Okay, so A vector is nothing but sum of the vector in X component and the vector in Y component. Normally we know this. If you want to find out the magnitude of A vector, you will do a magnitude of Ax into I vector plus magnitude of Ay into J vector, right? So, if you want to find out the magnitude of A vector, that is the resultant vector, what you will do? You will do the sum of the vector in X component and the vector of Y component, right? So this is what we mean by splitting of vector. Okay, say this A vector we have split into X component and Y component. Okay, so this is what we mainly mean by resolution of vector. Okay, and here what is important is, if you know this and this, you can find out this, right? But here, if you know magnitude of A vector and this alpha and angle alpha, we can find X component, X component and Y component. Okay, so this is what we mainly concentrate in resolution, right? So this is our X component, and this is our Y component, isn't it? Right? So if you know magnitude of this guy and if you also know alpha, this angle with respect to x-axis, alpha is with respect to x-axis and here beta, if I write beta, it is with respect to y-axis. Okay, so any of the angle, if you know this angle or this angle, what you can find? We can find, the magnitude of, magnitude of X component and Y component. Okay, so I repeat once again, when you know the magnitude of resultant vector and this angle alpha, we can find magnitude of X component and magnitude of Y component. Okay, so this is what mainly we study in resolution of vector. So resolution means one resultant vector we are splitting into X component and Y component. Okay, so we are describing a vector, a resultant vector in terms of X component and Y component. Okay, so this is what we mean by resolution of vector. So now let us see how we can find X component and Y component if you know the magnitude of resultant vector. Okay, so it is very easy. You just have to apply a trigonometry here. Guys, let magnitude of X component be ax. Okay, so ax I vector, its magnitude, let it be ax. Okay, and like that, and magnitude of ay into j cap, let it be ay. Okay, and magnitude of a vector is our resultant vector, let its magnitude be a. Okay, so x component's magnitude, let it be ax, y component's magnitude, let it be ay, and a vector, that is our resultant vector's magnitude, is just a. Okay, so now just observe what is cos theta. I mean, okay, I considered it as alpha. No, what is cos alpha? Cos alpha is nothing but base by hypotenuse, right? So what is that? Base divided by hypotenuse, right? So what is base? What is base? It is nothing but x component, that is ax into I cap, isn't it? So what is its magnitude? Its magnitude I considered as ax, right? So that means ax divided by a. Okay, a magnitude of a vector, this much is a vector, right? So cos alpha is equal to ax by a. So how do you find ax here? ax is equal to a into cos alpha, right? So a into cos alpha, this is how you can find magnitude of x component. Okay, so ax is what? Magnitude of x component, isn't it? So magnitude of x component is found by this particular formula. It is a, that is resultant vector's magnitude, if you know that, multiplied with cos alpha. Okay, so similarly, your sine alpha is what? This much, perpendicular by hypotenuse, right? So what is perpendicular? This is nothing but this, no, ay, right? So it is nothing but ay by a. Sine alpha is equal to ay by a. So ay, this is magnitude of y component. Ay is equal to a into sine alpha, right? So this is how you can find magnitude of x component and magnitude of y component. If you know what magnitude of resultant vector, and this alpha is what? Angle with respect to, this you should not forget. So this is the angle with respect to x component, okay? So that is what very, very important. Clear, everyone? So now if I consider this angle with respect to y component, what is our ay? If I consider beta as the angle, okay, what is my ay then? It becomes ay is equal to a into cos beta. It is not ay is equal to, it's not always, if you consider alpha as the angle, then ay is equal to a into sine alpha. Okay, but if you consider beta as the angle, ay is what? Ay is equal to a into cos beta. Okay, so cos is always, with respect to the angle, to a corresponding axis. Okay, so anyway, if this is the angle, then what is x component? How do you find the magnitude of x component? A into cos alpha. If you consider alpha as the angle, then what is the magnitude of y component? It is a into sine alpha. Okay, so this is what we mainly study under resolution of vector. Okay, now we will see a problem on this particular concept. Look at this problem, guys. An aeroplane takes off at an angle of 30 degree to the horizontal. Okay, so let this be an horizontal. Okay, and aeroplane is taking off, it flying at an angle 30 degree. Okay, so let this be at an angle 30 degree. So this is aeroplane, okay, and this is let it be AX component. If the velocity of plane is 180 kilometer per hour, that means, okay, so velocity of this aeroplane vector is 180 kilometer per hour. Fine. Calculate its horizontal and vertical component. Horizontal component is AX. Okay, what is vertical component? AX into I cap. Vertical component is AY into J cap. Right? So you have to find out, mainly the magnitude of AX and the magnitude of AY. So you have a formula, right? So what is our formula? If you want to find out AX, what is AX? AX is equal to A into cos alpha. So this angle is nothing but alpha, isn't it? So what is A? A is nothing but resultant vector. This is our resultant vector, velocity of aeroplane. So what is its value? Magnitude of A vector is 180. So it is 180 into cos 30. Right. So 180 into cos 30 is how much? It is root 3 by 2. Isn't it? So 2 ones are 2 nines are. That means AX component is equal to 90 root 3 kilometer per hour is the answer. So horizontal component, when a plane was moving in this direction, it can be split up into two components. I mean, in the horizontal component, the velocity is this much. What about the velocity in vertical component? That means AY. AY is equal to A into sine alpha, isn't it? So what is A? 180 into sine alpha is sine 30. So 180 into sine 30 is half. So that means AY, this is vertical component. How much? It is 90 kilometer per hour. Okay, so that's how you can calculate X component and Y component when this particular information, this is how an information was given. Okay, so that's all about a problem on resolution of vectors, guys. See guys, this is another simple conceptual question. A vector is given. A vector is equal to 2i cap plus 4j cap. B vector is equal to 3i cap minus 5j cap. Find 2a vector plus 3b vector. You have to find the sum of 2a vector and 3b vector. But they gave a vector and b vector. First you try to find what is 2a vector. A vector multiplied by 2. So we are using the concept of multiplication of vector with a real number. So 2a vector is how much? 2i plus 4j cap multiplied by 2, right? So 2a vector is equal to, how much do I get? It is 2 2s are 4i cap plus 2 4s are 8j cap. Right, so this, let it be equation 1. And now similarly you have to do what? 3b cap, 3b vector, okay, is equal to, what is b vector? It is 3i cap minus 5j cap, right, multiplied by 3. What do you get? You get 3b vector is equal to 3 3s are 9i cap, right, minus 3 5s are 15j cap. So this is your equation 2. Now what you have to find? 2a vector plus 3b vector, right? So 2a vector plus 3b vector is equal to, what is 2a vector? 2a vector is this one, equation 1, that is 4i cap plus 8j cap, right, plus, and the 3b vector is how much? 9i cap minus 15j cap. Okay, see, when you add I components, you add, Y components you can add. Okay, so this is how you can add usually in terms of I cap and J cap. All I cap things you add and all J cap guys you add. So 9 plus 4 is how much? It is 13 I cap. Okay, and here it is 15 minus 8 is how much? Minus 7 j cap. Okay, so this is your answer. So hope you are clear with the additions in terms of I cap and j cap, isn't it? So when they ask you some question like this, giving a vector and b vector, first you multiply them with suitable numbers, then you add all I components, and later add all j components. Okay, so this is all about the resolution of vector, multiplication of vectors, and what we have studied are subtraction of vectors, right? So all the concepts of vectors has been clearly explained. So with this I complete vectors. In my next videos you can expect me going through motion in a plane, where we first discuss about position vectors and displacement vectors. Okay, thank you so much. Keep learning, keep revising the topics, and all the best. Meet you all in the next videos. Take care.